So for part 2 of the exercise, they say that we should try to construct the proof for the opposite implication. So instead of having for all x a implies b, we have for all x a implies b implies for all x a implies for all x b. We have the opposite, so for all x a implies for all x b implies for all x a implies b. And then they want us to tell us why this proof will not succeed. So I'm not going to make you wait through me completing this unsuccessful proof. I'm just going to start. So we here, oops, these are the rules. We have, we use the same approach as last time, and we essentially try to apply this rule here as soon as possible, because we want to introduce this fresh variable as soon as possible, so that we don't have to introduce many new variables and not conclude the proof. So in order to use the rule, I first use the right implication rule to move this onto the left side. So I've moved this onto the left side, and then I can use the right for all rule here to put in a fresh x prime and substitute and have the substitution here. So this is great. And now that we've reached this line here, we can use the right implication rule again and split up so that we have the a with x substituted for x prime on the left side and b with x substituted for x prime on the right side. Here we can use we're using the left implication rule again, and then we just move the for all b onto the left side, onto the left branch, and the for all a onto the right side on the right branch. So from this point forward, we can just try to finish the proof and see why this actually doesn't work. So on the right side here, we have a where x is substituted for x prime, and we have for all x b, which we would like to turn into this here so that we can finish the proof. Now let's see what rules we can use. We can use this rule over here. This works perfectly because that means that we can just add a substituted version of the a, in this case b, in our next line. So we'll just use that rule. We'll have for all on the left side, and then we have a x prime, for all x b, and then what we want, which is b x prime. And on the left side, the right side, we have b x prime. So that's perfect. Now we have closed that proof because we have a b here and a b here, so that's great. And now if we have a look on the right branch, we want to have turned this a, which is on the quantifier, to an a where x is substituted by x prime. So what rule can we use here? Well, since the quantifier is on the right side, we need to use this rule here. And this rule here requires that we use a fresh x prime. Now, we'd already used x prime, so the fresh one, I'm just going to call x double prime. So x double prime is fresh. And then we'll apply that rule. So we have a x prime, that's the same. G, and then we have b x prime, that's the same. And then this turns into a x double prime because we want to use the fresh one here. Now, we could try to conclude that these are the same and these are the same and then we're done, but that is actually not the case. The reason why is because x prime and x double prime are not the same variable, so these aren't the same. So we can't finish the proof here. So what else can you do? We can try to. Oh wait, I forgot to write. Whoops, I forgot to write that we have for all xa. So we still have for all xa from this rule here. So we could try to apply the rule over again and substitute it with another fresh variable, but we cannot do this, or we can keep doing this, but a new fresh variable will not help us. We still won't be able to have that the left side and the right side have the same well-formed formula. So we have to conclude that since we never will be able to make these two match up, no matter how many times we apply this problem, that we cannot actually close this right branch. So that's why we cannot construct or finish this proof.